going to hide a couple of things, so just give me a moment. Okay. I'll just put that over there. Actually, hold on. I'm trying to hide some things here. All right. All right. So happy Thursday. We're almost through the first week. Y'all are doing great. I'm trying to make sure to respond to everybody who introduced themselves in the forums. Sorry if it got repetitive, if you read several people's comments. I'm teaching 2 classes, so I have I think 63 students. So it's a lot, but I want to make sure I do my best to get to know people and to get to know who they are, because when you're taking all your classes online, one of the hardest things is getting to know your instructors, especially when it comes time like for when you're applying for scholarships and you want to start getting letters of recommendations and things like that. It's hard to make those connections with instructors well enough to ask them for that. So that's one of the reasons I really try to build those relationships and make those connections with my students as much as possible. It's hard with 30 something students and being online class, but I will, hopefully at least a few of you, as many as possible, make those connections and be able to have a good time. So today's objectives. I'm kind of excited about lab 1, but anyway, before that, we're going to finish up 2.1 by constructing pie charts. That's a pretty quick little thing. I don't know why I don't include that on the Tuesday class. I'm not sure. I just don't. So we're going to do pie charts, and then we're going to jump into section 2.2, and we're going to start organizing our data in tables. We're going to construct a histogram with discrete data, and then we're going to organize continuous data in tables and with histograms. We're going to do my least favorite type of graph, which is a stem and leaf plot, and then talk about shapes of distribution. After we do all of that, after we do all of this lovely visual stuff, we're going to do lab 1. I will walk you through step by step how to do lab 1 and do examples for you. Hopefully you collected all your data. If not, that's okay, because it's not due till I think Tuesday. So it's absolutely okay if you haven't collected your data yet. So don't freak out if you haven't done it yet. And I had something else. It's gone. Well, it's been a really long week. First week back after winter break, it's always quite a long week. So let's get rolling. Try not to keep you guys here too late. All right. I don't know why. So yeah, I do know what I'm doing. Okay, so we have 2 different data sets here. We have the marital status of U.S. residents 18 years or older in 1990 and in 2006. So we're comparing the percent of people, in millions, never mind, not percents. We're comparing the number of them in millions in those 2 years. So you can look here. In 2006, there's about the same number of widowed. There's more of every other category, but it looks like the married has actually, they've all kind of increased by close to the same percent. I think married's increased by a bigger percent than most of the other ones. Anyway, this is just our data. I'm going to move on here, and we're going to calculate relative frequency of both of these, because they're kind of meaningless because we're not looking at the same number of people. Obviously, you can tell by looking that we have more people in 2006 than we do in 1990. So we're comparing apples to oranges. So we want to look at the percent so that we can, or the relative frequency, so we can be comparing oranges and oranges rather than apples and oranges. So here we go. Actually, I calculated relative frequency. So remember, you take the number in that category and then you divide it by the total number of people. I created a relative frequency table here. So it looked like every category had more in 2006 than did in 1990. But once we create a relative frequency table, you can see that in 2006, we have more people who never married. We have fewer people who are married, fewer percent are married, close to the same are widowed. We have a higher percent that are divorced. So with relative frequency, it's a lot easier to compare two data sets. Because if I would have just created a frequency table, it would have looked like everything went up for 2006. But using percents or the relative frequency, you can see that it's not the case. This is a much better picture of the actual statistics. All right. So let's talk about pie charts. So you've all seen a million pie charts, I'm sure. So pie charts are a circle. It's divided into different sectors. Every sector represents a category, and the area of the sector is proportional to the frequency. So if half of my people have a certain category, then half of my pie chart is going to be filled in. So I'm going to take the 2006 people and the frequency of each of those of their marital status. So I've got the 2006 ones, and we're going to make a pie chart. I'm never going to ask you to make one of these by hand. Don't worry. I will ask you to make one by using in the lab, and it's super easy in Excel. You will see. If you did make one by hand, you would have to use a protractor, and then you would need a protractor. You would need something to make a nice pretty circle. It would be a lot of work. They're actually kind of fun though. I recommend it if you have a protractor handy, but I don't think everybody's a nerd like me and keeps one handy. I'm just the weirdo. Okay. So, we would calculate, if we were constructing this by hand, you would calculate the degrees, that is the proportion of the 360 degrees, but otherwise it's going to look like this when you make them in Excel. So I can see the percent on each of my slices. And this is a pretty nice picture that you can tell everything. It's a nice visual, and it's pretty easy to compare each of the marital statuses. Sorry if my cat's being super loud. It's really nothing I can do about it. Okay. So let's talk about, we've already created frequency distributions and relative frequency distributions from discrete data. Here is a whole bunch of data. This represents 50 households and how many available cars they have. So I'm going to put them in a table. I do want to sidebar real quick here. I want to talk, there's going to be a couple of questions. You may have already had them, I can't remember, that talk about cumulative relative frequency. So all cumulative relative frequency does is I'm going to make an additional box over here. So all cumulative relative frequency does is it just adds them up as I go along. So this right here is 0.08 is my relative frequency. For the next box, I would just add together 0.26 and 0.08. So this would be 0.34. Then for the next box, I'm going to add the 0.34 to the 0.44, 0.78, and so on and so on. So then this would be 0.92, 0.98, and then 1. So what this does is it's actually not super helpful, but what it does is it just adds them up. It's cumulative. It adds them up as we go along. So I can see 92% of the people have 3 or fewer cars in their household. Without adding them all up myself, it's already there. I'm never going to ask you to use a relative or to make a cumulative relative frequency table, but there's a couple of questions in your in my open math that have cumulative. So it might say what percent of households have 2 or fewer cars? And on the cumulative, you would just be able to see it's 78% because it added up the 0, the 1, and the 2. So that's all cumulative relative frequency is. All right. So jump back in. This was my frequency table and my relative frequency table. So if I am making a histogram, the histograms are slightly different than bar graphs. So the rectangles, same. It's going to have rectangles just like a bar graph. The height of the rectangle, just like a bar graph, is the frequency or relative frequency of the class. This right here is slight difference right there. That's the difference. The width of each rectangle is the same, but the rectangles will touch each other. So a bar graph is going to look like this, like that, and a histogram is going to look like this. There we go. So that's kind of the difference between the two. Most of the time, histograms are usually used for continuous data. Sometimes they're used for discrete, but usually we use histograms for continuous data and bar graphs for discrete. There is some overlap there. We can do discrete histograms, which we're going to do one in a moment, but most of the time, a histogram would be continuous and a bar graph would be for discrete. Any questions before I show you the histogram? All right. Okay, so once again, we have our car data right here. We have our relative frequency table and our frequency table. And I'm going to do a relative frequency and a frequency histogram for the number of cars. So here's actually, I don't think I did both of them. I think I only have one of them. So here's my frequency graph for the number of cars. So once again, with discrete data, my label is directly underneath, smack dab in the middle underneath the bar on the histogram. So it's in the middle. My bars touch each other. And then the height of the bars is how many cars there are, how frequently it shows up. When using discrete data, I don't find histograms quite as visually appealing, but it is what it is. Do I have the relative frequency? I do. There's the relative frequency. I mean, it's basically identical except for its relative frequency along the side instead of frequency. Okay, that's for discrete. We're going to jump into continuous, which is where we mostly use histograms. So when we have continuous data, I just dropped my Apple Pencil. When we have continuous data for our histogram, we have to organize our data in classes. So these, or if we have like a large number of different discrete values, so it's either continuous or large number. So like if my discrete data went from 0 to 100 or 1 to 100, you're probably not going to give each of those values a bar. You're going to group them like 0 to 9, 10 to 19. You're going to group them into smaller groups or classes. Another word for classes is bins, and you're usually going to hear me call them bins. It's mostly because Excel calls them bins, and usually when I'm making histograms, I call them bins. So bins and classes are exactly the same thing. So each of our classes would have to be the same size. So if my discrete data that went from 0 to 100, I would do 0 to 9 and then 10 to 19, 20 to 29. I wouldn't do weird things like 0 to 8, 9 to 12, 13 to 28. You're going to make sure that your bins are all the same size. Okay, moving on. So the following data represents number of persons ages 25 to 64 who are currently work disabled. So this is discrete data, but because we go all the way from age 25 to 64, you're not going to give each person their own bin, their own bar. So therefore, I put them into size 10 classes, 25 to 34, 35 to 44, etc. So I put them into their classes. Stop it. Clementine, she's driving me crazy. All right. So the lower class limit is the smallest value in the class. So this right here is the lower class limit. The upper class limit is the largest value in the class. I know, it's like rocket science, right? You never would have guessed that. Okay. So the way that you could tell the class width is you would just take two consecutive classes and you would subtract their lower class limits from each other. 25 minus 35 is 10. My class width is 10. Now, this is probably going to annoy you, but there is no like rule. This is the class width you choose. There's no rule for that. It's kind of up to you to decide. And um, you're going to hear me say this over and over and over, but statisticians don't deal in absolutes. Most things don't have an absolute rule. A lot of things are a little bit wishy-washy and kind of can be moved one way or the other in order to make it more appealing. We work on things, making things visually appealing, in a lot of cases, or sometimes we'll choose pretty numbers because we want it to be more appealing, like what numbers we're using. So you just kind of have to deal with it. It took me a while to be okay with it, but it is what it is. All right, let's move on. Okay. I didn't make a histogram out of that. I was just showing you the bins. Here, however, we have the time between eruptions of Old Faithful Geyser in Wyoming. So this is all of the data. There's 45 different eruptions. They took measurements of time, how long in seconds between each eruption. And here's all the data. It's lovely. It's lovely data. I like it. Okay. So my smallest data value is 672. But because we like things pretty, we choose a nice number. I think they call it a convenient number. I call it a pretty number. I'm going to choose a pretty number slightly below my smallest data value. So I choose 670 because I would rather my lowest class start at 670 just because it's a pretty number. Then the number of classes I'm going to have is just going to be, I'm going to keep going until all of my data is covered. My highest number is 738. So my last class is going to end at 739. Every class, I've decided to make it 10. And rule of thumb, and it's going to be on another screen, but I believe that our textbook and this slideshow say between 5 and 20 bins is what we want, or classes. But generally we do between 5 and 12. 20 is a lot. So generally we do between 5 and 12 classes. Please don't go below 5 classes, 5 classes / bins. It's not a really great way to show the data because we have too much in each bin. So your best bet to make your display meaningful is to be between 5 and 12 classes. Okay. Okay, so let's take a look at the classes that I created. So each one of my classes is 10. So I went 670 to 679, 680 to 689, 690 to 699, on and on and on and on until I have everything covered, because 738 is my highest number. 672 is my lowest. And I have nice, pretty numbers here. So let's take a look at what that looks like. Okay. I created a frequency and relative frequency table. So what I did was I took a look at my data and I counted how many data values are in each bin. Yes, this one is 0. Having some that are 0 is okay. But if I ended up with 3 bins in a row that were 0, I would want to change my bin width so that I don't have this big weird gaping hole in the middle of it. Remember, we want it visually appealing. So if you have, if I had, let's say there was 1 there, and let's say that I had another 0 here, that's okay. But I don't want to have like 3 zeros in a row. I want to have it visually appealing, as I said. I'm going to show you 2 different histograms, one that has a lot of gaps and one that doesn't. And you'll see that one is definitely more visually appealing than the other. So here we go. Take a look. Actually, I don't think I showed both graphs. So this one I have 1 by itself. Take a look here. I have 3 bins in a row. I changed it to a 5 class width. I have 3 bins in a row that have 0 in it. And the first 2 bins only have 1 in each of them. So I would end up with all this humongous gap right in the middle. It's not going to be pretty. So the 10 makes more sense because I'm not going to end up with this big gap. Because we want it to be visually appealing and we want it to also be meaningful. Let me show you my graph. I think it's on the next page. It's not, darn it. Okay. Before I go any further, are there any questions? Other than how to get my cat to be quiet. I can't do it.
So you said the class width was the smallest. It was, hold on, I have it written down, sorry. It was the smallest minus, or the biggest, isn't it the range? I don't,
It would be this one minus this one. So 675 minus 670. So the class width here is 5.
oh, okay, so you don't do it for the whole thing.
Well, you don't have, because they're all the same width, you only have to do it once. So you just take 2, and it doesn't
Oh,
matter.
okay, I get it.
Two.
I,
Yeah.
that's the easiest question I could have asked. Okay, thank you. I was like, okay, just,
I can absolutely guarantee there was someone else sitting there going, I'm not sure. I'm sure there's always someone else that has the same question as you. So just ask it.
thank you.
Uh-huh. I don't think there's any dumb questions. I don't, okay. I take that back. There are occasionally some dumb questions. I mean, I am divorced. You can guarantee that my ex asks dumb questions. All right. So let's talk about determining class width. Now, I'm going to tell you that this is what the book says. Um, I don't like it. The book gives instructions to do something and I don't like it. And I'm going to tell you that you're more than welcome to use their method, but I'm telling you, I don't like it. Okay. First thing you want to do when we're taking care of our finding our class width is you choose your lower class limit. That is always the first thing you're going to do. And as I said, I choose a pretty value. See, it says convenient number. I choose something pretty. You can't hear my cat, really? She is so loud. Oh, man, I can't believe you guys can't hear her. She's so loud. Okay, sorry. Thank you. Thank you, Ellie. Okay. Anyway, so you choose your lower class limit first, no matter which method you're using to get your bin widths. There she is, by the way. She's right behind me. I'm going to show you guys. Let's see if I can. I don't think you can see her unless you're looking at the little picture of me. It's Clementine. She's just a baby. Okay. Anyway, so after you find your lowest class limit, this is how the book says to do it. She's really sweet. I didn't want a cat, but my daughter's cat had kittens, and this cat was terrified of everybody. My daughter wasn't going to get rid of her. She was scared of everybody and super meek, and so I'm like, okay, I'll take her. And now I'm in love with her. I cannot imagine life without her. Okay, so what the book tells us to do is to decide how many classes you want, and then you take your smallest data value or what you're choosing for the bottom of your class and your largest data value, and you divide it by the number of classes you want. The thing is when you do this, you're going to end up with weird sizes of classes. So for example, our data, when we were at 670, see, 670 to what was the last one? Second, I'm going to go back there to 738 to 738. So if I was doing that, I'm going to do it backwards. So 738. So let's say, okay, I'm going to pick a weird number. I want to have 8 classes. So 738 minus 670. That's going to give me 6. Something's weird. Okay, now divide it by 8. That would give me 8.5 in each of my bins. That's just weird. So I don't want that. So in my opinion, it makes much more sense to just decide I want a class width of 10. I want a class width of 15. after you do that, you can be like, okay, that's not enough bins. I'm going to change my class width. To me, that makes more sense. It's more efficient. This gives you weird things. I'm like, okay, now it's at 8.5. So what do I need to do? Do I need to move my lower number? Do I need to change my bin number? So my recommendation, choose a class width on your own. And then after you have tell Excel to make the histogram, then you can say, you know what, I don't like that. It's not giving me enough bins or it's giving me too many bins. So then change your class width a little bit to adjust it. That's my recommendation. I'm going to show you how to do it when we do the lab. Right. You don't have to listen to that recommendation. You're more than welcome to do this. I'm not going to mark you down for it. All right. I'm considering a Roth IRA. And you collect the data on, this is on page 79 in table 12 in your book. Just in case you wanted to know, I took this directly from your textbook. This represents a 5-year rate of return in percent adjusted for sales charge for a simple random sample of 40 mutual funds. I'm going to construct a frequency distribution of this data. There's my frequency distribution. So what I did was I made my bin width 1. So it's 8 to 8.99, 9 to 9.91, et cetera, et cetera. Yes, I have these two here that are zeros, and I might have wanted to change it to, I could have changed it to 1.5 instead. But for some reason I didn't. I just left it here. I think I actually am not super comfortable with 2 blank ones right there. But I think probably the reason that the table in your book chose to keep it this way was because 8 to 8.99 is much prettier than 8 to 9.49. And then you would have 9.5 to 10.99. And that, I think that the statistician that wrote your book decided that it was prettier to keep it 1% than it was to get rid of the 2 zeros by each other, if that makes sense. So visually appealing always tends to win out for some reason. Okay. Now, this is what Excel will do. I'm just showing you. If you don't customize the bins, Excel does this for you automatically. So it didn't use my bin widths. I just kind of want to show you what Excel will give me. So if I got this from Excel, see, it has bin widths of 1, but it goes 8.28 to 9.28, 9.28 to 10.28. It's, I think this is really ugly. I don't like that I have 3 empty bins here. So if it was me, I would be adjusting some things because I would move this to go down to 8 and still keep my bin width 1, and it's going to even it out nice and pretty. And I'm going to show you how to do all of that. Oh, something else I'm going to go back to the geysers. When we have a histogram, oh, hold on a second here. Where's my geyser? I can't find that histogram. Did I pass it up? Where's that histogram? Okay, I didn't go back far enough. I'm sorry about that. Bim, bim, bim. There we go. No, how come, did I not give you a geyser histogram? What's wrong with me? Okay, I'm gonna have to sketch something here real quick. I don't know what's wrong with me. I don't know what happened to the geyser histogram. All right, so with a histogram, because you're going to be reading some of them. So this is called calling an audible right here. Da, 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 da. Isn't this a lovely histogram? Isn't this the most beautiful histogram you've ever seen in your life? Okay, so we're going to start at 0 right here. So if this is 10, whoa, what the heck? If this is 10 and this is 20 and this is 30 and then this is 40, this number right here is it's the lower bound of the next histogram, of the next one. So here, let me find a highlighter. So that is the lower bound of this box right here. We don't label the lower and the upper. You only label the lower bound of the next higher one. So I know that this one starts at 10 and I know that it's going to end right before 20. Then the next bin starts at 20 and ends right before 30, and et cetera, et cetera. So I don't know what happened to the geyser histogram. It left. I need to fix that. But hopefully you get the gist. Okay. I can't believe how fast we're going through this, which is good because we're going to do the lab. So this is good. All right. I'm going to tell you stem and leaf plot. My least favorite and type of graph, but it is in our standards, so I have to teach it. And I think you're going to have a few questions in the homework, but I am telling you, I will not test you on stem and leaf plots. I don't find them useful. If anybody can finds a way that they're useful or finds some representation of them that is more useful than another way to display data, please post it in the forums, because I've never found a time when stem and leaf plots were more useful than some other method of displaying your data. But I'm going to show you how to do them. You will get them in your homework. They're just not my favorite. So the way the stem and leaf plots work is you have this, obviously the stem and the leaf. So we organize our data. Oh, that is still a highlighter. Oh my goodness. You're going to organize your data so that the stem, why isn't my pen working? There we go. So your stem is going to be everything except for the last digit. So as this says, 147 would be 1, 4, and then 7 over here. Then if I had 148 also in my data set, I'd put the 8 there. I have another 148. I'm going to put that 8 there also. So, and then 149 would be right there. And then I have 150. So maybe I had 153, another 153, 158. And this is how we organize our data. So the hundreds and the tens place is over on the left, and then the ones place is on the right. This is a stem and leaf plot. We're gonna be doing a couple of them here, a couple different examples. Okay. Here's my geyser eruptions. I reorganized these so they're smallest to largest because I needed them for my stem and leaf plot to make it more organized. So I'm going to turn these into a stem and leaf plot. My stem will be the hundreds place and the tens place. My leaf will be the ones place. So I'm going to pop over here. The reason I have two 72s here is because sometimes when the leaf is going to be too long, too big for one stem to go onto one stem, or I just think it's, once again, not visually appealing because it sticks out too far, we will split it in half so that the first 72 is going to get 720 through 724. The second 72 is going to get 725 through 729. That whole visually appealing thing. Then again, I don't find these too visually appealing anyway. The way that we do these is, so like I have 672 and 678. I didn't have any in the 680s. I have 695 3 times. I have 696, 698. I have 699 twice. I'm just going to write all these in here really quick. What? No. Uh-oh. It's not letting me. Okay. It says it reached my usage limit. Okay, give me a moment. I have to switch to PowerPoint. Okay. Yay. Stem and leaf plots. There we are. Present from current. Okay. Actually considering that I had to install something, that didn't take terribly long. Sorry about that. Let me really quickly write on here where we were. See, the writing's not as nice and it doesn't do as fancy things as the other program. And I don't have an undo button. 1, 1, 3, 4, 4, 6, 8, 9, 0, 1, 1, 2, 2, 3, 3. Okay. Okay, 1, 3, 5. And also it randomly changes colors on me. All right. So this is my stem and leaf plot. Now, when we look at the stem and leaf plot, it looks pretty meaningless. So what we have to do is we have to have a key. So you're going to write the word key, and then you pick any random data value. I don't care what data value you choose, any random data value. I'm going to choose 698. So I would say let 69, then a vertical line, 8, represent 698 seconds. So you have to have a key. You choose one data value and you have to write down what it means. That way, when somebody's looking at this, they can see like, okay, I see there's a 711 seconds there. So this is not, as I said, this is not my favorite. So I had something. It was in my brain. It's gone. All right, we're going to look at another data set and look at another stem and leaf plot. So this data set right here is the unemployment rate. I don't know what year. It's an unemployment rate in the US. I have all 50 states here. So when you are first setting up your stem and leaf plot, at least when I do it, I put them in there and they end up out of order and ugly, just like this. So this right here, though, is my whole number. And then these right here are the decimals, so the tenths place. So basically your decimal point is right there. When we're dealing with decimals, that's kind of how this goes. So we would definitely need a key here, but I'm going to go to the nice pretty one first because this one, they're all out of order. When you do a stem and leaf plot, your leaves need to be in order smallest to largest. So when I first, usually what I will do is I'll take my raw data and I will just throw it onto the stem and leaf plot. And then after that, I organize it and make it pretty like this. Now they're all in order and it looks pretty, but you need to have your key because somebody looking at this isn't going to understand anything that's going on. So I'd say I pick one, let's say 4, 3 represent 4.3%. So this is my key. And this is going to tell you what's happening and what your stem and leaf plot represents. Right. Questions about stem and leaf plots?
When you said that on that original one, you had two 72s because the data values were so spread out.
Yeah, so if I would have put these on here, notice how it sticks way out farther than the rest of them. And basically somebody decided that that's not pretty, and so we just split them in half. And that's just it's just a personal choice. You don't have to ever do that. But some people choose to do it when the leaf gets too long and they just want to make it more compact. So you just split it in half. You'll all learn that stats is kind of weird, and sometimes we just make choices because it looks better or sounds better. And as long as your math is sound, there's a little bit of wiggle room on style. And that's kind of what I like about stats is in the beginning it drove me crazy, but I do kind of like that we can make some stylistic choices here and there. Okay, get back to where I was. Okay, now this stuff is important. Shape of distribution. We're going to be talking about shape of distribution pretty much the entire term. So being able to recognize the shape of distribution is it's a little kind of important. I don't test you directly on this, but you're going to be using this knowledge in some other ways. I don't know how to exactly say it. So I think in your homework, I think you're going to have questions about it, but yeah, you'll see. But it's important and it's not too difficult, so you should be okay. And so one of the ways that we describe a variable is we talk about its shape of distribution. So when we graph it, we will look at its shape and how it's distributed. So here's the first one, uniform distribution. So with a uniform distribution, the frequency of each value, of every value is spread out evenly. Now, it's not necessarily going to be exactly even. It could be really close. And as I said, statisticians don't deal in absolutes. So sometimes if it's really close, we will say it's mostly uniform or relatively uniform. So it's possible that I could have like this one right here might go up slightly more, and maybe this one over here slightly down, and it's still basically uniform. It's basically we have a nice rectangle. So it could be slightly off and still be considered uniform. But you're not gonna, if I had one that's stuck way up here, now it's not uniform at all, if that makes sense.
Is the shape of distribution the same as classification of graphs?
Possibly.
Like it, like it's just telling you what the graph looks like by like bell, like skewed, that kind of.
Yes, 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 yes.
Okay, okay.
Yes, exactly. And it's kind of like we're starting off with shape, and then once we start talking about like normal distributions and things like that, then we kind of start calling it classification. I hate that we call things different things as we move on. Kind of like relative frequency is going to be turning into proportion, which turns into probability. It's all exactly the same thing. We just change the name as we move on, and I'm sorry about that. It's not me. I didn't choose it.
Thank you.
Yes, thank you. All right, next, bell shaped. This is a nice, pretty bell shape. If I drew a line over it, that's not perfect. It would be bell shape. We also call it symmetric. Symmetric because basically, if I folded it in half right here, it would mostly land on itself. Now, once again, we say words like relatively bell shaped, mostly bell shaped, basically bell shaped. So you have to use, we use that kind of language. So it's, if it looks pretty close, we can call it bell shaped. And this is like the gold standard. This is what we want. We want bell shaped. Most of the analysis that we do requires us to have bell shaped. And there's things we do if it's not, but most of it we want bell shaped. Okay, next. This one is skewed right. And it's exactly the opposite of what you would think it would be. But when we talk about skew, we talk about that it has a tail on the right. Most of my data is bunched up on the left, and I have this big long tail on the right. Where the tail is where the skew is. So this one is skewed right because it has that tail on the right. This one is skewed left because it's got the tail on the left. Most of my data is bunched up over there on the right, so the tail is over on the right, on the left. This one's skewed left. All right. This one right here. So think about it, think in your head, answer. What is the shape of this distribution? This one is a beautiful bell. This one is a lovely bell shaped. I love this. So beautiful. So it's nice and symmetric. About this one. This one is skewed right. Figured I should probably write that on there. This one is skewed right. You can tell that because it's got that tail off to the right. It's nice and pretty. All right. Next, this one right here. You said skewed left. You are correct. Pat yourself on the back. This one is skewed left. Good job. I bet you could guess without even seeing it what the next one's going to be. That one is uniform. That one is a nice, lovely uniform distribution. All right. I think that's my last slide. That is my last slide. Ah, don't allow. Okay. Questions for the questions before we go to the lab. Questions on the lesson. All right. So we're going to do the lab now. Once again, remember you need, I'm going to actually write it down one more time. Before we get to the lab, I'm going to write down one more time the 3 types of data you're going to need. I'm trying to change my pen color. There we go. So number 1, you're going to need 20. Each of them, you only need 20 data values. I'm going to let you know that the lab itself, on the lab, it says, why won't the L work? What's going on here? Trying to write there and it's not letting me write. Okay. So on the lab itself, on the instructions on the Excel spreadsheet, it says 50 data values. Basically, I'm rewarding those who either watch the instructional video or are in class here by saying you only need 20 data values. You don't need 50. So you kind of get rewarded for following directions. So 20 data values, you need 20 categorical. See, my handwriting was better on the other program too. You need 20 continuous. And you need 20 discrete. And I'm going to give you a heads up. The only data of these 3 that we're going to use again in future labs, I'm going to have you use your continuous data again in lab 2. So if you want to choose something you're more interested in for continuous, you might want to do that. Otherwise, if you don't really care, it doesn't matter. But we are going to reuse the continuous data. We're not going to reuse the categorical or the discrete. But just if you wanted to make it something more interesting, feel free to do that with continuous. It doesn't matter though. All right, I'm going to put my iPad down because this is all going to be computer.
Can I ask a question about how to think through the difference between continuous and discrete?
Okay. So go ahead.
Okay, so I emailed you. I was the one that used the Kentucky Derby race data for the last 20 years.
Oh, that was beautiful. I was
So
from ear to ear when I was reading that. Go ahead.
okay, so my categorical data is the color of the horses, each horse. My continuous data is the finish time that they finished the Kentucky Derby race in, and the discrete data is the number of wins that horse had in its career. But so for the discrete, I mean, you could say the horse won 1 race, 2 races, 3 races, 4 races, all the way up to the. So how do you think through, like, is this discrete or is this continuous?
So discrete, they can't win 2 3/4 races. They can't win 2.85 races. They have to win a whole number of races, something that you can count. Continuous, if they're running, if something takes 38 seconds, they had to go through every single time up until that to hit that. Like every teeny tiny little increment, they had to be at 20.348792 seconds before they could get to the next one. But I'm going to win 1 race, then I'm not going to win 1.85 races. I'm going to win 1 race, and then I'm going to win a second race. You're not going to have anything in between them. Does that help at all?
Yes, that helps so much. Thank you.
Okay. Because if you were going to graph it, discrete, you would have dots on a graph. Continuous, you would have a continuous line on the graph. So make sure though when you're doing those times, don't do minutes and seconds separate. you could convert it all to minutes or all to seconds. Otherwise, the Excel is going to have issues. So you could, seconds would probably be your best bet.
They did include the times down to tenths of seconds, which I didn't include, but I could go back and retrieve that.
If you want to do that, that's fine. But just don't do like if you said like 3 minutes, 8 seconds or something like that, Excel's not gonna be happy. It's not gonna read it correctly. So you would either need to have it converted all the way to minutes or all to seconds. So if it was like 3 minutes and 8 seconds, it would be 188 seconds instead. So just make sure that you're doing that, because Excel will be unhappy with you and cause all sorts of problems. All right. Any other questions before we move on to the lab? Okay. I'm gonna pop over there. There it is. There's my beautiful lab. Okay. So all of my continuous data set is the only one not made up. I made stuff up. I'm not going to give you permission to make stuff up, but how would I know if you did? But I like real data though. I love it when people get creative, like the Kentucky Derby thing. I've never seen anyone do that. And the fact that you took all three from the same thing, oh, that was just chef's kiss. It was beautiful. It made me really happy and it made me smile. So there you go. If you want the person grading your assignment to smile, then use real data. Okay. Not that I'm going to know anyway. So I have imaginary friends on Facebook and I ask them their favorite colors. This is my categorical data right here. So categorical data, my imaginary friends, I got their favorite colors. You need to list your raw data in this list right here. So over here on the left, we're listing the raw data. So I wrote favorite color right here because I wanted to say what my variable was. You don't necessarily have to write that right here because you're going to tell me what the variable is over here. But I wrote favorite color up here, and then I just typed down each one of them right there. I don't have 20 data values. Make sure you have 20, but I'm not being graded. So then over here, you're going to organize your data. So you're going to have to do it manually. So I just took each of the favorite colors. I typed them in the X values right here. And then I counted the frequency of them. And I just put the numbers here in my frequency table. Okay. Now we're going to come back to that in a minute. My population. Be careful with your population. My population is Facebook friends. My population is not favorite colors of my Facebook friends. No, the people I am studying are my friends on Facebook. So it is whoever all of the people are that you're studying, that's your population. The variable I'm studying my friends' favorite colors. Now, I don't care if you're interested in your population and variable. You do not have to answer that question. But if you are interested in it, I would love to hear why you're interested in it. But you don't have to answer that. Just tell me what your variable is. And just type it directly in here. I would just type in here my friend's favorite colors. Friend's favorite colors. And I'm going to try to spell it correctly. Okay. Colors don't have units. It's not feet, colors, feet, or anything. There's no units. So I'm not going to, but if you want to, I mean, you could type in colors, but there's no units. So you can leave that one blank. You could write no, actually, I would prefer you write no units rather than leave it blank because I want you to have the understanding that there's no units. I'm not going to mark you down if you put colors in there, but there's not really any units. Now, this question D here, why are you sure that your sample data is categorical? You're basically relying on the definition of categorical. I know that my data is categorical because it is words and not numbers. It is a characteristic of my friends or whatever. So, for example, with I don't want to do yours for you. I'm not going to do it for you. I was going to use your example, but I know it's categorical because the definition of categorical tells me that it is non-numerical data. So that's it right there. How and where did you get your data? If you got it from a website, you need to give me either the URL or the name of the website. Google is not a source. Like if you're using the colored jerseys of, or the main color in the logos on NFL teams' logos, main color, I went to NFL.com and got these colors. Um, my source was I asked friends on Facebook. My source is I sat on my front porch and looked at the cars going by. However you got your data, just tell me how you got it. All right, here's how you put your pie chart in. So down here, I am going to, whoa, sorry, I'm having issues. I'm going to highlight both of these columns in my frequency table. I'm going to highlight both of them. And then up here on the top, I'm going to click on Insert and go to, I usually go to Recommended Charts because almost always it will have the kind of chart I want in there. I want a pie chart. Okay, it gave me a pie chart. That was nice of it. Okay. Okay. So I have a pie chart. I'm going to make it bigger so y'all can see it. The pie chart is not yet exactly how I want it. Now you guys get a little bit of creative license here. You can do a little bit of your own, but what I do want from you, you have to have a chart title. You have to have it. Non-negotiable. Friends, favorite colors. Okay. You have to have a title. I also want you to I want you to have the percents on your on your pies. There's choices up here. There's all sorts of choices up here in your sections. I can change my colors, even though I'm going to show you how to change them individually because I don't want red to be green on here. I don't want brown to be purple. But you can choose. There's all these different styles. Take a look. All these different styles here. And I might find a style that I like that doesn't have percents on it, and I can add a chart element and I can add the labels where I want them and things like that. Like, take a look here, data labels. Let's put outside end. Let's put my labels out there so I can move my percents to the outside. And where else can I move them? I can move them into the center. So you can play with it a little bit. That's what I want you to do. The point of this is for you to play with it a little bit. Okay, so now though, I want to change my colors. I'm going to just double click on my chart and notice this little paint thing here. I'm going to change. I'm going to click on this one here. This one's supposed to be blue. So I'm going to change this one and make it blue. This one is supposed to be green. I'm going to change it to green. So you can change. Oh, that's ugly. I don't like that green. That's better. Okay. So I can change these to be the actual colors. I'm not going to be mad at you if you decide that you want to be silly and keep them the wrong colors. Nobody's going to be mad. This one's going to be red. I just can't handle it. All right. Now my brown looks kind of green, but it's okay. So I want you to play with this a little bit. The only requirements I have is that you have a title and that you have the percents. There has to be a legend, but the legend's not going to go away. So make your nice, pretty pie chart. All right. Any questions on the pie chart and categorical before I move on to continuous?
I have a really quick question.
Okay.
So when you go to insert, you go to recommended charts. Is
Yes.
that where you go? Okay.
Yeah, and I mean you can, so I could have just chosen pie chart directly from here and then picked one I liked, but I usually just go to recommended and see if it has my choice for me already.
Okay. Thank you.
Yeah, it's totally up to you.
Okay.
Okay. Any other questions before I move on? All right, continuous. So my continuous data is the magnitude of earthquakes around the world. It was the greatest magnitude of earthquakes in different countries. I went a little crazy and I have like 100 and something on mine. I wouldn't expect that of you. But anyway, so my population is just the whole world, countries of the world. And then my variable is earthquake magnitude. Now, I kind of wish I wouldn't have chosen earthquake magnitude because earthquake magnitude technically doesn't have units. Your continuous data is going to have units, most likely. So it's going to be something like feet, inches, miles, degrees, units. It's just, yeah, feet, inches, miles, degrees, whatever your units are, dollars, whatever your units are, that's what you're typing down right here. Once again, why am I sure my data is continuous? Think about the definition of continuous. How and where did I get my data? Same thing. All right. So you do not have to do this piece right here. Excel has changed the way it does histograms. You no longer have to put this right here. I did this, but you do not have to fill out this chart. I do want your interval width. You can wait to fill that out until after you've created your histogram because you might not like the width you chose. So wait and fill that out until after you've done your histogram. All right. My histogram is not going to be pretty when I first place it. We're going to have to play with it a little bit. So I'm going to highlight all my data. Mine is gigantic, just FYI. So I told you it's like 130 something. And I'm going to show you some tricks. Okay. So I highlighted all my data. Once again, I'm going to go to recommended charts. I'm going to scroll down. See, I have a nice pretty histogram right here. Yeah. Actually, this histogram is not terrible. Okay. Let me go here. All right. So before you make any changes at all, choose the histogram you want. So I might want to have some colors in here. I don't like with the red one. Let's go with purple. I might want to change colors. If you want to choose a different style of histogram, you can choose a different style first. Do that before you do anything else. So I don't like that one. So choose whatever style you like. Okay. After you do that, once again, you have to have a chart title. Earthquake magnitudes. I can't spell earthquake, apparently. You may recall that I told you you have to have axis labels. We do. You have to have axis labels. So I'm going to click on my chart here. Go over here to add chart element. And we have axis titles. I need a horizontal. Go back there. I need a vertical. So here my axis title would be magnitude. Uh-oh, I didn't mean to do that. I didn't mean to double click. Magnitude. And then this one right here is going to be frequency. Everybody's vertical is going to be frequency because that's what the type of histogram we have. Everybody's is going to be frequency. This one is going to be different. So notice when we look at, I'm going to make this a little bit bigger. Notice when we look at my bins here. Yes, I have a good number of bins. 1, 2, 3, 4, 5, 6, 7. 7's not a bad, but I don't like my bin width. You are more than welcome to leave ugly bin widths if you want. I don't like my bin widths. So I'm going to double click on my whole graph. I might have not been what I was supposed to do. It wasn't. I'm going to double click on my on the actual bars, the bars on my histogram. If you double click on the bars of your histogram, this is going to open and I have this right here. If you can, I can't make it bigger. Hopefully you can see that. This makes automatic bin widths. I'm going to change my bin widths. I want it to be 0.5. And it's going to change things. Now, if you are somebody who wants a certain number of bins, you can do that. So let's say I wanted to have 8 bins. I could do that and it'll give me 8 bins. But I like to choose my bin width because that's just me. I want my bin width to be 0.5. Beautiful. This is also where you can change other things. I mean, You can change so that I have no fill. That's weird. Solid fill, gradient fill, all sorts of stuff like that. You can change colors and texture, and so play with it and see if you like, I can do those automatic. So feel free to play with it a little bit and see what you like. You might like some interesting style. You might like some weird 3D stuff. I don't like that. I like things a little bit simpler. Okay. Now I'm going to show you, now once we're here, I have my bin width at 0.5, and that's now that once you are where you have your bin width chosen, put that up there. Okay. I want my lowest value on my histogram not to be 4.4, but I want it to be 4. Because remember, we like to choose pretty numbers. So this is just kind of getting tricky. What I do when I want my histogram to have pretty numbers instead of the funky, ugly ones, I'm going to cheat. Going to my lowest value, and I'm going to put the actual amount right here. My actual amount is 4.4, but I'm going to change my lowest value on here, 4. Once I do that, this is all still accurate. My histogram's still accurate because that 4.4 would still be inside this bin. But now I have pretty numbers. This 4.4 that I put here reminds me that that's a 4.4 and not a 4. But now I have pretty values on my histogram. It's still completely accurate because I still have the correct things in the correct bins, but it's just pretty. You don't have to make it pretty. This is just a Melissa thing. This is just something I like to do. All right. That's my histogram. So questions on the continuous before I move on to discrete.
Yeah, oh, go ahead. Sorry, someone else is speaking.
I was just gonna say, does the raw data have to be in order on this one, or can it be like out of order going down the line?
Raw data is usually out of order. So out of order is just fine. You just type it in as you find it. So, if you're going through a
Okay,
list,
thank you.
just type it in as you find it. I specifically put mine in order just because I wanted to easily find the small one to change it to make it pretty. It was just for this instructional purposes.
Okay, got it.
Okay.
Is it okay to put them in order if we want to?
Yeah, absolutely.
Okay. Because for my continuous, I chose like birth weights and I just collected it from family members and friends.
Okay, so if you're doing birth weights, make sure that you don't have pounds then ounces. Make sure you convert it
Okay.
all to pounds or all to ounces, or maybe if you're doing
Okay.
kilograms or grams or whatever, but make sure you convert it all to 1 unit, because once again, Excel's going to be mad at you if you don't.
Okay.
Okay. Anyone else? All right.
Yeah, sorry. So it says on the it says explain how well your sample represents your population.
Don't even worry about that. All I want to know is how you got your data.
Okay, okay, that makes sense.
It's right in front of me, but I forgot that question was even there. So all I really care about is how did you get your data? You're just giving me your source.
Okay, thank you.
Good question. Thank you. All right. We're ready for discrete. Discrete, this one's going to be super fast because I'm not giving you a whole lot of information here. I chose number of children, so I just went through my Facebook feed, took 20 of my friends and typed out how many children they have. So here we go. Actually, it's more than 20, but this is my discrete. My population is my Facebook friends. All of this is the same. You're probably not going to have units because if you wanted to type children in here, that's fine, but you're probably not going to have units. So just either type in no units, or you can just type in, like I did, children. But you're probably not going to have units. All right. So this one, you are going to choose your own graph. What I want you to do, so I organized once again, I created a frequency table here. But you're going to go in here and you're going to look at the different graphs. I want you to look at different things, and I want you to find something that best represents your data. whatever that may be. Even if you use one we've already used, that's fine. But I just want you to explore the different graphs and I want you to choose one that you think best represents your data. I am not going to mark you down for choosing a bad graph. I'm not going to do that. Um, but I really just want you to kind of play with it. So the discrete is specifically for you to kind of play with it a little bit. Have some fun. But make sure that if you have axes, make sure your axes are labeled and make sure you have a title on whatever graph you choose. Make sure there's a title and make sure you answer the questions. But and as I said before, I don't care why you're interested in your variable, but just tell me what your variable is. All right. That's it. That's all I have. So questions while we're still recording. Any questions you have while we're still recording?
For the interval width in the continuous data set, is that what we were using with the bins? Was that the number that we used there?
Yeah, so notice my bins are 4 to 4.5, so my bins are 0.5. So
Okay.
whatever your bin width ends up being, that's your interval width.
Okay.
Okay. Anyone else?
Quick question. On the pie chart that we did, did you show us how to manually change the colors or did I miss it?
Yeah, I can do that. So double click. I can't make this bigger. It won't get bigger. But if you see this paint can to the left, so on the paint can, if I click on, like I've clicked on the green pie slice, there's a little drop down right here. It says color, and I have a little drop down, and I can choose whatever color I want for that slice. And now if you wanted to do something cool like texture fill, or you actually can upload pictures, insert your own pictures in there to fill. But to me, it's super busy and I'm not the biggest fan of super busy. But if you want to do it, that's fine. There's all sorts of ways that you can fill it, but this paint can right here, and then you can click on each individual slice and change them all on their own. Does that help?
Perfect. Thank you.
Welcome. Anything more?
I'm realizing on my racehorse data, sorry, I don't know if you can hear my dog now, my pet is making noise. Like all the horses finished the race in 2 minutes, in a range of 2 minutes flat, and the longest one is 2 minutes 4 seconds. So all my data would fit inside like 3 bins. So, but if I include tenths, I can spread that out more.
Yeah. So include the tenths then, and maybe go to like if you can get to 5 bins, that would be
Okay.
great. Will you be able to
And
get
did
to
you
5?
say for, I think so, especially if I include tenths. I might even be able to if I get, because they do go from 2 minutes flat up to 2 minutes and 4 seconds. So I think that gives me 5 bins.
Okay, perfect.
And then was it just a bar graph for the discrete data?
The discrete data is whatever graph you choose. You play with it. Find whatever. I want you to go in and look at all the graphs and choose something. So you guys have some creative license here. Choose whatever graph you think best represents your data. So look at all the graphs that Excel has to offer and whatever you think best represents your data. So try some different things. I want you guys to play with it. You're not going to break it. All right. Anyone else?
Yes. So for an example of categorical data, would number of snow days Talent School District had in the last 20 years be a good example of that?
That would be discrete.
Okay.
Yeah. So an example of categorical, like it's things like colors or right-handed, left-handed, or breeds of dogs, or
Is that one like how many green gummy bears can I pull out of a pack of gummy bears?
no, but it would be what colors of gummy bears you pulled out. So if you're pulling gummy bears
Oh, okay.
package, you'd have green, red, orange, purple, whatever. So if you open a pack of gummy bears and you pull 20 out, just write down their colors. That would be discrete or categorical.
Okay.
Okay. And then make
Yes.
sure you eat those gummy bears, otherwise it doesn't count.
Well, I was thinking I would include my kids in on them, so I thought they would love that.
Yes, there you go. And
Yeah.
have your kids tell you what colors they are, and then you can just type them in.
Perfect.
Make it a teaching moment, right?
Yeah, that's what I was thinking of actually.
I love that. Absolutely love that. See, now you're making me smile too.
Thank you.
No problem. Anyone else?
One last question. For discrete, would the population be the same as the units?
You mean like if you're using population of something for your discrete data?
Yeah, so
I mean, it'd be units is like people, but I mean, it's not really units, but it kind of is. So you can type that in as people for units if
okay.
you want. Or if
So-
your population of like of a fruit fly would be, I guess, fruit flies. But
Okay.
okay. Anyone else? Right. I'm going to stop the recording now. I don't know why I couldn't figure out how to